or to this presentation. I'm your host, Mwanza. So just read the information, then we answer these two questions. Chlorine can be made by the electrolysis of concentrated aqueous sodium chloride as shown by the following equation. So this is the equation where we have sodium chloride plus water will give us sodium hydroxide plus chlorine gas and also hydrogen gas. And then 55 decimeter cube of 3.5 mole per decimeter cube aqueous sodium chloride is electrolyzed. So the first one here is write a balanced chemical equation to calculate the maximum volume of chlorine that can be formed at RTP, which is room temperature and pressure. So having the information, this is the volume of sodium chloride and this is the concentration for sodium chloride. Okay, so first thing we're going to write the chemical equation. So we'll say solutions. So in this solution we just copy what we have given, then we balance this equation. Okay, so let's do that. So here we have something like this. So as you can see here, sodium is 1, and then chlorine here it's 1, chlorine there it's 2. We have hydrogen 2, oxygen 1, then oxygen 1, hydrogen. So here this side hydrogen we have 3 hydrogen, the other side is what? 2. So we need to balance this. So there is chlorine, we also have chlorine 1, so here you add 2 in order for us to balance this. So we're going to add 2 this side. So once you add 2 this side, then what else? So even this sodium is going to be affected, so you also add 2 where there is sodium. So here sodium we've got 2 sodium, chlorine 2, chlorine 2, you've balanced. Now oxygen here we've got 2, there we've got 1. So where there is oxygen you also add 2. So where there is oxygen is here where there is water, so you add a 2 there. So hydrogen you've got we've got hydrogen 4, then here hydrogen is 2 plus this one there is 2, then it is what? Balanced, you get full mark, just answering like that. So we proceed to the second question where we need to calculate the maximum volume of chlorine that can be obtained at RTP. First thing, we have the prerequisite information that we need to use. So this is the first information that we have been given. So here it is very simple for us to find the moles of sodium chloride. Then we use the same mole to find the ratio for another what for chlorine. Okay, so we'll do like this. So we'll write the first formula where we have been given what we have been given there is the volume. Volume is equal to volume for this sodium chloride, it's 55 decimeter cube. Then concentration Tc is equal to 3.5 mole per decimeter cube. So this is what we have. The number of moles we don't have, so we use this same information to find the moles of this sodium chloride. So now the formula here, it's concentration is equal to mole over volume. So concentration we have been given, then this volume we have been given, so we want the mole. So we just do like this, then this and this, this and that. So this and this, it will be N, which is mole, is equal to C times V. Where this is concentration, this is what? Volume. So we just substitute. So it will be N is equal to C is 3.5 mole per decimeter cube, then times 555 decimeter cube. So this and this unit will do what? Will disappear. Then you just remain with this mole. So you just pan this on the calculator, and then you get the moles of sodium chloride. So the moles of sodium chloride, when you use your calculator, it will be 192.5 moles of sodium chloride. So here we're saying sodium chloride. So this is the mole of sodium chloride. So having this one, remember this is just a way of finding what we have been asked. So we use the same equation, the balanced one. So we have this mole, the sodium chloride here, and then we also have chlorine here. What they want is the volume of chlorine. So we are going to use the mole of sodium chloride to find the mole of what? The same chlorine. Okay, to find the mole of chlorine. So we'll say, we'll take a simple formula which will be like this. Mole of chlorine, we'll say mole of chlorine, it is sodium chloride like this, over is this one, then over the coefficient of this compound is what? 2. So write 2 is equal to, then again the mole of chlorine, this side is just chlorine, this is sodium chloride, so this side is just chlorine, this one here, the mole of this chloride we don't have, so just write the mole of chlorine gas, which is like there's a 2 there, then the coefficient there is just 1, so down there I'll just say 1. So these numbers down represents the coefficient of the compound. Okay, and then where there is sodium chloride, we write what we've calculated, which is this one, the moles. So this one is the one that we're going to write here. So let's just replace. So there we are saying we write 192.5 moles over 2. So this is mole. Okay, moles is equal to, there it will just be number of moles, which is what, for chlorine. Okay, for chlorine it will be like this. Then this one into this, so we are going to find half of this. So half of this is going to be, we'll say mole is equal to 96.25. This is moles of chlorine. Moles of chlorine. Okay, so this is number of moles of this chlorine gas. So this is what we've calculated. Where you find the half of this is going to give you this one. Then this mole is for chlorine. So now, having this mole for chlorine, then we are told to find the volume at RTP. So let me use this. Okay, we'll just write it down here. So the formula that we are going to use is, we have been given the moles, so we'll say mole is equal to volume over molar volume. So this is molar volume. This one represents molar volume. This is the volume that they want us to calculate, and this is the number of moles of what? Chlorine. So here the molar volume at RTP is 24 decimeter cube. So this is the molar volume at TP. Then this one we have. So this one, even when you check on the project table, you find this number down there. It is shown, or it has been indicated the volume at LTP. So we proceed to find the volume of chlorine gas. So we say here it will be like this. So this and this, it will be V is equal to N times molar volume. So we'll say V is equal to our NEHC 96.25, and then times 24 decimeter cube. Okay, so this is the molar volume. So what we are calculating is volume. So once you multiply this and this, we'll get our answer. You find this on your calculator, then you will compare the answer. So my calculator here is giving me 2310 decimeter cube. So this is the answer that I'm able to get. So this is the volume. So we can say therefore maximum volume of chlorine is 2310 decimeter cube at LTP. Okay, at room temperature and pressure. So this is the final answer. This is the final answer. I hope you are able to see this clearly. So please feel free to comment, to ask questions, and share to others. Thank you.